In this video, you will get your very first real look inside Unreal Engine, and see how powerful and easy it can be to bring your ideas to life. You will learn how to set up your project, move around the editor like a pro, build simple blueprints that make your world interactive, and see how materials and lighting work together to make everything look stunning. We will also explore how to add ready-made assets from Quixel Bridge and the Fab Store, and how to set up complete levels in just a few clicks. By the end, you will know exactly how to get started with your own scenes, props, and animations. All explained step by step, beginner-friendly, and directly in Unreal Engine 5.6. If you want to learn how to build your dream game, this is where it all begins. So grab a coffee, open your project, and let's get started. We start by downloading the Epic Games Launcher because we need it to work with Unreal Engine. Head over to the epicgames.com website and click the download button in the top right corner to get the launcher installer. Once the download is complete, run the file to begin the installation process. Follow the setup instructions step by step. Normally, the installation only takes a few moments because it mainly installs the core files for the Epic Games Launcher, which is the tool we need to download and manage Unreal Engine later on. When the setup has finished, the Epic Games Launcher usually opens automatically. Sometimes a small window appears asking you to update the launcher. If you see this, simply confirm the update so you always run the latest version, which keeps everything stable. After the installation is done, launch the Epic Games Launcher. You will see the sign-in screen. Here you can create a new Epic Games account or log in using one of the many available options like Google or PlayStation. This gives you full access to everything you need for Unreal Engine. Once you have signed in, you will see the Epic Games Launcher home screen for the first time. Let me quickly show you what you can find here so you know your way around. By default, you will first see the store page. This is where you can buy games from Epic Games or other developers. One day, your own game could appear here too, once you have built and published it. That is exactly what we are working towards, so keep that goal in mind every step of the way. A quick tip. If you scroll down a bit, you will find the free games section. Every week, Epic gives away new games for free that you can claim and keep forever. Right now, there are 2 free games available, so feel free to grab them as a bonus. Next, we have the library section. This library is for all the games you own through the Epic Games Store. Here you can see which games are already installed on your system and which ones are ready to download or update. Think of it like your personal shelf for all Epic Games titles, including any free games you might have claimed earlier. Finally, there is the Unreal Engine tab, and this is exactly where we want to go now. When you open it, you will first see the news page. This page keeps you up to date with the latest Unreal Engine news, like the recent release of version 5.6, which is the version we will work with in this video. The news section is useful to quickly catch announcements about new features, bug fixes, or community events. One thing I definitely want to highlight here is the roadmap. The roadmap shows you what Epic Games is planning for future Unreal Engine versions and what is currently being developed or tested. It is worth checking the roadmap from time to time so you always know what improvements and new tools are on the horizon for your projects. Here in this tab, you can access the roadmap for each version of Unreal Engine. For example, we select version 5.6 here and see all the planned or recently added changes. If you click on an entry, you often get a short description with extra details. It is always smart to check this regularly so you stay up to date and know what new tools or improvements are coming your way. Now let us move on inside the Epic Games Launcher. The Samples tab gives you access to a collection of free example projects and learning templates. For instance, the game animation sample is quite advanced and shows how professional-level animation setups work. However, if you are just starting out, this can be overwhelming, so I recommend starting with smaller, simpler projects first to really understand the basics step by step. Next, we have the Fab Store. This is the digital store for 3D assets, materials, and plugins that you can use in your Unreal Engine projects. It used to be called the Marketplace directly inside the launcher, but today it has been moved to its own platform. We will take a closer look at the Fab Store later when we actually need to bring assets into our project. Then there is Twinmotion. Twinmotion is a powerful visualization tool mainly designed for architects and designers. It allows you to create high-quality real-time presentations of buildings, landscapes, or other large scenes without needing deep knowledge of game engines. Many people use Twinmotion to turn architectural plans into vivid, walkable visualizations that clients can explore interactively. We also have Reality Scan here. Reality Scan is a tool that helps you turn real-world objects into 3D models using photos taken with your phone or camera. It uses photogrammetry to create detailed, realistic assets that you can bring directly into Unreal Engine for games, visualizations, or VR projects. This is especially useful if you want to add authentic props to your scenes. Finally, we get to the library. This is the section we need right now. The library shows you all the Unreal Engine versions you have installed, plus any projects you have already created or downloaded. From here, you can launch your engine version, update it, or manage your existing projects. It is basically your main hub for everything related to your Unreal Engine work. In my case, you can see that I already have Unreal Engine version 5.5.4 installed. Down here is my fab library, which lists all the assets I have purchased. You can add these assets to any project you are working on or even use them as a starting point to build a new one. Now let us click the small plus icon at the top to install a new engine version. You can actually have multiple Unreal Engine versions installed at the same time, which is really useful if you want to test new features without risking changes to your main project. Click the small arrow next to the plus icon to open the version list. Here you can choose which version you want to install. For this course, select version 5.6 or simply pick the latest stable release available to make sure you work with the newest tools and improvements. Unreal Engine version numbers follow a simple convention. The first number, 5, means the major engine generation. The second number, like 5.6, marks a big update within that generation. Sometimes there is an extra third number, like 5.5.4, which shows smaller updates or bug fixes for that version. After you have selected your version, click Install and a new window will appear. This installation window lets you choose the folder where you want Unreal Engine to be installed. It is a good idea to pick a location with enough free space, as engine files can get quite large over time. Once you have set the path, click Install again to start the process. In the bottom left corner, you can click on Downloads to open the Download Manager. This lets you keep an eye on the progress and see how long the installation will take. During this installation, the Fab Unreal Engine plugin and Quixel Bridge are installed automatically too. The Fab plugin connects your project with the Fab store so you can easily import assets and manage them directly inside Unreal Engine. Quixel Bridge is another super handy plugin that gives you direct access to the huge Quixel Megascans library, which is packed with high-quality scanned textures, models, and surfaces you can drop into your scenes. Both plugins are included by default so you can start working with professional assets right away without extra setup. After the setup is finished, you will see a new Unreal Engine icon on your desktop that you can use to start the engine anytime. Or you can simply click Launch here in the Epic Games Launcher to open Unreal Engine, in our case version 5.6. When you launch the engine, it needs a bit of time to start up because it is loading all core data, plugins, and settings in the background to get everything ready for your projects. Once the engine has finished loading, you will see the Unreal Engine project browser. By default, the Recent Projects tab is open. This shows you a list of projects you have worked on recently, so you can quickly jump back into any ongoing work without having to search through folders. On the left side, you now see all the available templates. In the Games Templates section, you will find different starting points for various game types. For example, the first-person template sets you up with a basic character and camera already configured for a first-person perspective. In version 5.6, this template has been improved with updated controls, enhanced input mappings, and a clean folder structure that makes it easier to understand and extend. The third-person template gives you a fully working third-person character with movement, jumping, and a follow camera. This is a great starting point for adventure games or any project where the player should see the character from behind. The top-down template sets up a camera looking down at the scene from above. This is perfect if you want to create a strategy game, a point-and-click adventure, or an RPG where you control your character from a top-down view. There is also the handheld AR template. This gives you a foundation for augmented reality projects on mobile devices. It includes basic AR tracking and camera setup, so you can place virtual objects in the real world using your phone or tablet. Another option is the virtual reality template. This template prepares your project with the right settings, input mappings, and example scenes for VR headsets. It helps you get started with immersive experiences right away without having to manually configure all the VR-specific setups. Finally, there is the vehicle template. This gives you a basic drivable vehicle with physics and input controls already set up. It is a good choice if you want to build a racing game or any project that needs realistic vehicle movement and handling right from the start. Next, we have the film, video, and live events category. I will not go through each template here in detail, but this section gives you starting points for projects like virtual production, film pre-visualization, or live broadcast setups. These templates help filmmakers, video producers, or event teams create scenes with real-time rendering, camera setups, and lighting ready to use in a professional production pipeline. Then there is the architecture category. This one is mainly for architectural visualization. It includes templates that help you create realistic interior or exterior scenes, often with high-quality lighting and materials, so architects and designers can present their buildings or spaces in an interactive way. Next comes automotive, product design, and manufacturing. This category offers templates for industries that need detailed product presentations, car configurators, or interactive prototypes. It helps designers and engineers build realistic visualizations of vehicles or products, test ideas, and present them in real time with high visual fidelity. Last but not least, we have the simulation category. These templates are for projects where you need to create training simulations, virtual walkthroughs, or any scenario that recreates real-world environments for education or technical demos. They come with example setups that show how to handle interactions, user guidance, or physics-driven scenarios. So, you can see there are many templates here for nearly any type of project you can imagine. These starting points are perfect if you want to learn and explore different workflows quickly without building every system from scratch. For this tutorial, we go back to the games category and choose the third-person template as our starting point. Now, on the right side, you will see a few settings that change depending on which template you selected. First, you can choose whether to start your project using only blueprints or with C++. If you pick blueprint only, you can build all your logic visually without writing any code, which is perfect for beginners or rapid prototyping. And if you ever need more advanced control later on, you can always expand your blueprint project with C++ code anytime. For this project, we stick with blueprint to keep things simple and clear. Next is the target platform setting. Here you decide whether your project will run mainly on desktop devices like Windows or Mac, or on mobile platforms like iOS or Android. This choice sets up some default configurations in the background, like input methods, performance optimizations, or rendering settings that match your target hardware. For example, mobile projects use different texture compression and lower default quality to keep things smooth on phones and tablets. Below that, you have the quality preset. This controls the default graphics quality for your new project. If you plan to test on a high-end PC, you can go with maximum to get the best visuals right from the start. Of course, you can adjust all quality settings later in your project to find the right balance between performance and looks. Finally, there is the variant option. This lets you pick a special version or gameplay style for your chosen template. For example, with the third-person template, you can switch to different variants like combat, platforming, or side-scroller. Each variant comes with extra pre-configured gameplay features. Combat gives you a starting point for action-focused mechanics, with settings that make it easier to build attacks or enemy behavior. Platforming sets up movement and jumping controls that fit classic platformer games with obstacles and levels designed for vertical and horizontal challenges. Side-scroller creates a 2.5D platformer style where your character moves on a fixed plane from left to right, combined with a side-scrolling camera and advanced jump features. If you select none, you get the default setup without any special gameplay tweaks, so you can build your mechanics from scratch. For our project, we stick with none because we want full control over how we create our gameplay step by step. Finally, down here you can set the path where your new project will be saved and give it a name. I am calling this project First Step and then I click Create to generate it. The first time you create and open a new project, Unreal Engine needs a bit more time to get everything ready. This is because it has to set up all the folders, compile shaders, and prepare the project structure in the background so you can start working smoothly. After the engine finishes loading, we now see our Unreal Engine editor for the first time. In the bottom right corner, you will probably notice a message saying new plugins are available. This shows up because Unreal Engine regularly checks for new or updated plugins that might be useful for your project. It could be new features from Epic or plugins you have enabled in the project settings. You can review these notifications and decide if you want to activate any of these plugins now or keep working with the standard setup. By default, when you start, you see the standard Unreal Engine layout. Take a moment to get an overview of this workspace, because we will break down every part in detail step by step. In the center, you have the viewport. This is your main working area where you build and preview your levels, place objects, and see your game world in real time. On the right side is the outliner. This panel shows a list of all the objects currently in your level, organized in a hierarchy so you can quickly find, select, and manage everything in your scene. At the bottom is the content browser. This is your main storage for all your assets like materials, meshes, blueprints, and textures. From here, you drag and drop things into your level or organize your project files to keep everything clean and easy to find. We begin with the viewport. If you hold down the right mouse button and move your mouse, you can freely look around in your level from any angle. While holding the right mouse button, you can also use the W key to move the camera forward, S to move it backward, and A and D to move it left and right. This is the same simple WASD control scheme you know from many games, which makes navigating your level feel really natural and quick right from the start. If you hold the right mouse button and use the scroll wheel, you can change the camera movement speed, making it faster or slower depending on how much space you need to cover. The current speed is shown at the top center of the viewport, so you always know how fast you are moving. You can also click on this number to open a small slider that lets you adjust the camera speed more precisely. There is even a field called Speed Scaler where you can enter an exact value if you want really fine control over how fast the camera flies through your level. This is super handy when you need to move quickly across large maps or slow down for detailed placement work. If you are working with a large map and do not want to search for the same spot over and over again, you can hold Ctrl and press 1 to set a camera bookmark at your current position. Later, just press the number key 1 and you instantly jump back to that exact camera spot. You can use all number keys this way to create multiple bookmarks across your level, which saves a lot of time when navigating huge scenes. Up here in the perspective menu, you have several useful settings to adjust your viewport view. For example, you can switch to orthographic views like top. The top view gives you a straight down look at your level without any perspective distortion. This is really useful for precise placement, checking your level layout, or aligning objects perfectly on the grid. Depending on what you are working on, you can switch between top, bottom, left, right, front, and back views at any time to get the best angle for your task. These are all features you will usually only need later once you are deeper into level design or fine-tuning your scene. If you click anywhere inside the viewport, Unreal Engine tries to select an object in your level. These objects are called actors. The selected object always gets a bright outline so you can clearly see which actor is currently active. Let us select the ramp here as an example. You will see the outline appear around it, and at the same time, a set of colored arrows and handles shows up on the object. These arrows are part of the transform gizmo. With this, you can move, rotate, or scale your selected actor directly in the viewport. You simply grab one of the arrows to move the object along the X, Y, or Z axis, or switch to rotate or scale mode to adjust its orientation or size. This makes it really easy to place and tweak objects exactly where you want them in your level. When you see the transform gizmo, each arrow has a specific color that shows you which axis it controls. The green arrow lets you move the object along the Y-axis, which usually means left and right in your level. The red arrow moves the object along the X-axis, so you can push it forward or backward. The blue arrow moves it up and down on the Z-axis, which is perfect for adjusting the height of your objects in the scene. If you press the space key while an object is selected, the gizmo switches from move mode to rotate mode. In rotate mode, you will see colored rotation rings instead of arrows. If you grab the blue ring, you can rotate the object around the Z-axis, which spins it left or right like turning a steering wheel. The red ring lets you tilt the object around the x-axis, which means you can lean it forward or backward. The green ring lets you rotate it around the y-axis. If you press space again, the gizmo switches to scale mode. Now you see colored boxes instead of arrows or rings. In this mode, you can resize your object along specific axes. Dragging the green box scales the object along the y-axis, stretching or shrinking it left and right. The red box changes the size along the x-axis, making it longer or shorter forward and backward. The blue box scales it up or down along the z-axis, which is useful if you want to make something taller or flatter in your scene. Now let us take a quick look at the details panel on the right side. When you have an actor selected, you see all its properties listed here. Under the Transform section, you can find the same three modes we just used in the Viewport: Location, Rotation, and Scale. You can adjust any of these directly by changing the numeric values for each axis, which is really helpful when you need precise placement or want to enter exact measurements instead of dragging with the gizmo. Next, look at the toolbar in the top left corner of the viewport. Here you can also switch between the different transform modes directly. The Select Objects mode, which you can activate with the Q key, lets you click and select actors without showing the gizmo. This is handy if you only want to select or multi-select things without accidentally moving them. The next icon is the Select and Translate Objects mode. This is the move mode that lets you drag objects around your level using the gizmo arrows to position them exactly where you want. The next one is the Rotate mode. This switches the gizmo so you can rotate objects in the scene, just like we did earlier with the colored rings. Finally, there is the Scale mode. This lets you change the size of the selected object directly in the viewport using the scale boxes on the gizmo. Now we have the World Space Coordinates mode. Important to know, switching between World and Local Space mode only works when you have the Select and Translate mode for objects active. This is because the World and Local modes control how your movement, rotation, or scaling axes align. When Select and Translate is enabled, Unreal Engine knows you want to adjust your object's position or orientation directly. Right now, we are working in World Space, which you can recognize by the globe icon next to the gizmo controls. If you click this icon, you can switch to Local Space mode instead. In Local Space mode, the Transform gizmo aligns with the object's own rotation. So when you move the object, it moves along its own local axes, basically, its own internal X, Y, and Z directions. For example, if you have rotated your object at an angle, moving it in local space will push it forward in the direction it is facing, not just along the flat world grid. If you switch back to world space, you will see the gizmo realign to match the global coordinate system. Now, when you move the object, it follows the standard world grid directions that stay fixed no matter how the object is rotated. Knowing when to use each mode is important. Local space is great when you want to move or rotate an object naturally based on its own orientation. For example, moving a rotated ramp or aligning a prop exactly along its own tilt. World space is best when you want to keep things lined up to the overall level grid, which helps you place objects cleanly and keep your scene organized. So when you switch between the coordinate systems, the gizmo automatically adjusts to match your choice. You can see right away how the arrows align themselves to the object and its current rotation. This makes it really clear whether you are moving or rotating along the global world grid or the object's local axes. This is a very helpful and important setting because it gives you full control when placing or fine-tuning objects, especially if they are rotated at unusual angles or part of more complex structures. Next, let us take a look at the magnet icon, which controls the snapping options. Snapping helps you place objects more precisely and quickly, and you have a few settings here to fine-tune how it works. The first one we will use is surface snapping. To see how this works, we need to focus on the gizmo itself for a moment. You will notice there is a small white dot at the center of the gizmo. If you grab this dot with your mouse, you can freely move the whole object around in your level without locking it to a single axis. Now, let us activate the surface option and enable Rotate to Surface Normal. With this setting on, when you move the object and drag it onto another surface, the object will automatically snap to that surface and align its rotation to match the angle of the surface below. This is really useful when you want to place props on uneven ground, walls, or any complex geometry and make sure they sit naturally without clipping or floating. Now, if we disable the Rotate to Surface Normal option and drag the object again, The snapping will still place the object directly onto the surface you hover over, but this time it will keep its original rotation. So instead of matching the angle of the surface, the object stays upright or in its current orientation. This is really useful when you want objects to sit flat on sloped terrain but still keep their intended rotation, like placing crates or props on a hillside without tilting them awkwardly. Now we set the surface offset to 100 and start moving the object. With an offset of 100, the object does not snap directly onto the surface anymore but keeps a small gap of 100 units above it. This is handy if you want to place something like a floating marker, a sign, or props that should not touch the ground directly. If we enable the Rotate to Surface Normal option again and move the object now, the object still snaps to the surface and aligns its rotation to match the angle underneath, but it keeps that 100-unit offset above the surface. So it follows the surface angle but stays slightly lifted. If we set the surface offset back to 0 and move the object again, it snaps flush to the surface with no gap at all. This is the default behavior when you want props to sit perfectly on the ground or any other mesh. Now let us check out the location snap settings and snap size. Location snapping locks your object's movement to specific grid steps so you can position things with precision. If we set the snap size to 100 and move the object along the wire x-axis, you can see it jumps in steps of 100 units each time. This makes it super easy to align walls, floors, or modular pieces exactly on the grid without small gaps. If we change the snap size to 1 and move the object again, the steps are much smaller, so you can nudge objects with fine detail and place them exactly where you need them. This is useful for small props or precise adjustments. When we switch back to a snap size of 100, you can clearly see how the object moves along the grid in clean steps of 100 units on all axes. This grid snapping keeps your level clean, helps avoid tiny gaps, and makes it easier to align everything perfectly when building modular environments. Now let us look at the rotation increments. Here you can switch between using fixed rotation increments or free rotation. The idea is that you divide the full 360 degrees into equal steps. For example, we set the increment to 45 degrees and switch to rotate mode. Now, if we rotate the object, it snaps in clean 45-degree steps. This helps you keep rotations exact and consistent, which is really important for modular pieces or mechanical parts that need to line up perfectly. But if we deactivate the rotation snapping here, you get free rotation again. Now, when you rotate the object, it moves smoothly and continuously on all axes without any fixed steps. This is great when you need natural angles, like tilting props or placing organic elements that should not look too grid-aligned. The same type of setting exists for scale. Here you can set a scale snap size, which controls how much the object scales up or down in steps. For example, if we set the snap size to 10 and scale the object, it grows or shrinks in clean steps of 10%. This keeps your scaling precise and makes sure objects stay consistent in size, which is especially useful for modular pieces or repeating props. If we switch the snap size to 1 and scale the object again, the scaling steps are much smaller, so you can make finer adjustments and get exactly the size you want without jumping too far in one go. If we disable scale snapping globally and scale the object, you get free scaling. Now the object changes size smoothly and continuously without any fixed steps. This is useful for unique props or when you want natural, less uniform variations. Next, there is actor snapping. When you enable actor snapping and move an object, it will automatically snap to other actors in your level when you drag it close to them. This makes it super easy to align props edge to edge, stack pieces neatly, or position things precisely without gaps. Then there are a few more snapping options. Socket snapping lets you snap one object to a socket on another object. This is often used for attaching weapons or accessories to a character's skeleton. Vertex snapping allows you to grab an object by one of its vertices and snap that vertex directly to another vertex in the scene. This is great for seamless connections or aligning corners perfectly. Planar snapping helps you move objects along a single plane so they stay locked to that axis or surface, which keeps your placement flat and tidy. And finally, on the right side, you see the small icon that looks like an umbrella. This is the quick toggle for surface snapping, the same surface snap setting we used earlier at the start. Here, you can turn surface snap on or off with one click and adjust its behavior without diving back into the main settings each time, which makes working with complex surfaces much faster. We have the same kind of toggle here for moving objects. You can turn snapping for movement on or off and adjust the grid size directly without opening extra menus. The same goes for rotation. You can quickly enable or disable rotation snapping right here and set your rotation step size in seconds. Finally, there is also a quick toggle for scaling. You can switch scale snapping on or off and adjust the snap size right next to it. These toggles basically give you quick access to all your main snapping settings, so you can work faster without constantly jumping into the full snapping panel. Now let us take a closer look at the toolbar on the right side. We already talked about perspective. Here you can switch between perspective and the different orthographic views if you need precise angles or top-down layouts. Next, let us check out the movement pilot. If you have an object selected, for example, in our case the SM Ramp 2, and click on Pilot, then hit Pilot SM Ramp 2, you can freely fly around the level with this object attached to your camera. You will notice from the shadow that the ramp moves with you wherever you fly, almost like you are carrying it through the scene. This makes it super easy to position big props in hard-to-reach spots or align them exactly while seeing the result from any angle in real time. When you are done, just click the stop or eject icon at the top to exit pilot mode. The ramp stays right where you left it in the world, exactly at the position you were flying when you stopped piloting. And if you want to undo the flight, just hit Ctrl+Z and the object jumps back to its original position. Next, you can adjust the field of view directly in the viewport. This changes how wide your camera sees the scene. A lower value zooms you in, which is great for focusing on small details, while a wider angle helps you see more of the environment at once. This is handy when framing shots or testing how your level feels through different lenses. You will also see new view plane and far view plane. These control how close and how far your camera can see in the viewport. The near view plane sets the minimum distance at which things are visible, useful if you notice clipping when you get really close to objects. The far view plane sets how far the camera draws the scene. Increasing it can help when working with huge landscapes so distant elements do not disappear too soon. Then there is the exposure game settings toggle. If you disable this, Unreal stops using the default game exposure and you can manually adjust how bright or dark your scene looks in the editor. Below that, the EV100 slider lets you change the exposure value manually. Higher EV values make your scene darker, lower values make it brighter. This is helpful for testing your lighting setup or for getting a clear view when working in very dark or very bright environments. Next, we have the bookmarks for your camera views, just like the ones we set earlier with Ctrl+1. Here you can quickly set new bookmarks, manage existing ones, or jump straight to any saved camera position without having to fly there manually. This makes working in big levels much faster because you always have your important spots saved and ready. Then there is the important setting called Game View, which you can toggle with the G key as a shortcut. When Game View is active, the viewport hides all editor-only helpers like gizmos, selection outlines, or grid overlays. You see your level exactly as the player would see it in-game, which is really useful for checking lighting, post-processing, and the final look without distractions. Last, let us talk about high-resolution screenshot. This option lets you take super sharp screenshots of your level straight from the viewport. It captures your scene at a higher resolution than your screen, which is great for portfolio shots or detailed previews. After you create a screenshot, Unreal saves it to your project folder under Saved, so you can open it there and check the result right away. That covers the perspective options for now. The camera section we already know, so let us move on to the view mode. Lit is the standard view mode. It shows your level with all lighting, materials, shadows, and effects active. This is what your players will see in the final game, so you will use lit mode most of the time for checking your visuals and adjusting your lighting. Unlit is a special view mode that turns off all lighting and shows your level with only the base colors of your materials. This is really helpful for checking textures, looking for UV issues, or testing how assets look without any shadows or lights affecting them. Next is wireframe. This mode shows only the geometry of your level as wireframes. You see all the edges and vertices without any shading. Wireframe is very useful for checking mesh complexity, seeing hidden details, and making sure your assets are well optimized for performance. Next is lit wireframe. This mode combines the normal lit view with a wireframe overlay on top. So you see your level fully textured and lit, but with the mesh edges visible at the same time. This is great for checking how your geometry flows together while still seeing how the lighting and materials look. You can even adjust the wireframe opacity here to make the lines more or less visible depending on what you need. Then we have detail lighting and lighting only. Detail lighting shows your scene with only the lighting and shading information, but without base material colors. This helps you see how the light interacts with your geometry and how smooth or rough your surfaces are. Lighting only goes a step further. It removes everything except the pure lighting data, showing you just the light and shadow intensity in your scene. This is useful for fine-tuning light placement and checking for dark spots or overexposed areas. Next is reflections. This mode shows only the reflection data in your level. It makes it easy to see how reflective surfaces like glass or water behave, and where reflection captures or probes are working. This helps you fix any reflection issues before they become visible in your final render. Then we have player collision. This view highlights the collision geometry that affects your player character. It shows you where your player can walk, jump, or bump into invisible walls. This is super important for level design because you always want to make sure players do not get stuck or walk through things they should not. Visibility collision shows you all the collision shapes that block line of sight or ray tracing checks. It is really helpful for debugging gameplay features like shooting, AI vision, or any system that needs to know what is visible and what is blocked in the world. There are many more view modes and special overlays you can use, but do not worry about all of them now. It is enough to know that they exist. Over time, you will learn which ones you need for your projects and when to use them. For now, having this overview helps you remember, right, there was a mode for that, so you can find it later when you need it. Now let us look at the show flags. This section is packed with options that let you toggle specific effects and elements in your viewport on or off. There are so many of them, but do not stress. You will get familiar with the important ones step by step as you build more scenes. One practical example is viewport stats. Here you can turn on real-time information like your current FPS and memory usage. This is super handy to see how well your level runs and how much system memory it uses, so you can spot performance issues early and keep your project optimized. Here on the right side, the FPS counter appears so you can see your current frames per second in real time. Let us hide that again for now. Another setting here is anti-aliasing. Anti-aliasing smooths out the jagged edges on your models and geometry by blending pixels together. This makes your scene look cleaner and more realistic, especially on detailed objects or when you have lots of fine lines. Then we have the atmosphere option. This toggles the rendering of things like sky atmosphere and fog. Turning it on or off helps you check how your level looks with or without environmental effects, which is really useful for outdoor scenes. Next, for example, we have clouds. This controls whether dynamic clouds are shown in the viewport. It is a simple switch to test sky visuals quickly without changing your full sky setup. Then there is collisions. This shows the collision shapes in your level, so you can see exactly where invisible physics boundaries are placed. It is handy for checking if players, props, or projectiles can pass through or collide with your objects as expected. There are many more of these toggles, and just like with the view modes, you do not have to know all of them right now. You will pick them up step by step as you need them for different tasks. One last thing I want to show here is static meshes. A static mesh is simply a non-moving 3D model like walls, props, or furniture. They do not have built-in animation or skeletons. Static meshes are the backbone of your level design because they build up most of your world geometry and decoration. There are too many show flags to explain every single one right away. Just remember, you will discover them naturally over time as your projects get bigger. Next is the Performance tab, but we will cover that later at the end. Now let us look at the gear icon. Here you can set options like the Level Editor Volume dB. This controls the global audio volume level for your entire level editor. It basically adjusts how loud or quiet the in-editor sound playback is when you test sounds, ambient effects, or preview audio cues directly in the viewport. This is very practical if you want to work on scenes with sound but not have them blasting at full volume every time you hit play. By adjusting the Level Editor Volume dB, you can keep background sounds at a comfortable level while you build and test your level. Next is mouse sensitivity. This controls how fast your camera view moves when you look around in the editor. If you set it to 1 and hold the right mouse button to look around, the camera responds very quickly and turns fast. If you lower it to 0.1, the movement is much slower and smoother, which is helpful if you want fine control when working on small details. Then there is mouse scroll speed. This adjusts how much you zoom in or out when using the scroll wheel. If you set it to 8 and scroll, you will see big jumps, which helps cover large distances fast. If you set it to 1, the scroll is extremely slow and precise. A value around 5 is a good default because it keeps the zoom smooth but not too aggressive. Next, there are options like invert middle mouse pan, invert orbit axis, and right mouse dolly invert. These just flip the direction of how your camera moves when you pan, orbit, or dolly with your mouse. So if you prefer the opposite behavior, you can switch it here to match your style. Now let us look at the viewport size settings. If you click the 3 dots, you get quick access to predefined layouts for multiple viewport panes. Right next to that is the icon for Restore Layout to show all viewports. This splits your workspace into 4 viewports at once. At the top right is your main default viewport. This is the one we have been using so far. In addition, you now get 3 extra viewports. When you move around in any one of these, the other viewports adjust too, so you always have a synchronized view of your level from different angles. By default, these extra viewports show top, front, and right orthographic views, which makes precise placement really easy. You can select an object in any viewport and it will instantly be selected in all 4. This makes it super fast to see and edit things from every angle without having to switch views manually. You can also adjust each viewport individually. For example, you can set the bottom right viewport to unlit mode to check your textures without lighting. The bottom left one could show reflections mode to check how reflective surfaces look, while the main perspective viewport stays in the standard lit mode for normal editing. The best part is that you can customize every viewport however you want, mix different view modes, camera angles, and snapping options. This lets you work on multiple parts of your level at the same time, with each viewport showing exactly what you need for that task. It is a super flexible way to speed up your workflow and keep full control over every detail from every angle at once. This whole multi-viewport setup is more for advanced work. Do not worry about using it right away. The main thing is that you have seen how it works so you know it exists and can come back to it when you need more control. When you click the 3 dots, you can choose from the predefined viewport layouts. And if you click the rectangle icon on the right again, it restores the default single viewport, so you are back to the normal workspace. Now let us look at the performance and scalability tools for the viewport. First, there is the real-time viewport option. When real-time is enabled, your viewport updates constantly. You see animations, particle effects, and lighting changes live as they happen. If you turn it off, the viewport only updates when you move your camera or interact with objects, which can help boost performance if your scene is very heavy. Next is Preview Platform. Here you can switch the viewport to simulate different target platforms like Android, iOS, PC, or consoles. This helps you see how your level will look and perform on different devices, so you can check things like resolution, shading, and overall quality early on. Then we have the viewport scalability setting. This lets you manually adjust the overall graphics quality in the viewport between low, medium, high, epic, or even cinematic. You can also tweak individual settings like shadows or effects one by one. This is helpful for speeding up your editor when working on big scenes. Drop the quality to low while you build, then switch back to high or epic to check the final look. Next is the material quality level. This sets how detailed your materials render in the viewport, from low up to epic. Last is the screen percentage. This controls the resolution scale for the viewport. You can turn on custom override and set it to a value like 25, which means your viewport renders at 25% of its full resolution. This makes editing heavy scenes much faster. Or you can push it up to 200, which renders at double the resolution for super sharp previews, useful for high-res screenshots or final visual checks. A value around 60 is a good balance for everyday editing because it keeps performance smooth but still looks clear. And with that, you now know the basics of how the viewport works, what options you have, and what is possible to adjust, all step by step as you grow your project. Next, let us take a look at the menu up here on the top left. First, we have File. In the Open section, you can create a brand new level or open an existing one. What you see in the viewport right now is your currently opened level, and you can always tell which level it is by looking at the tab at the top. The small orange mountain icon next to the name shows you that this tab is a level file. You can also add favorite levels or quickly reopen recent levels from this section, which is super handy if you switch between different maps often. Next, we have Open Asset. This lets you open any asset in your project directly from here, for example, a blueprint, a material, or a mesh, and it opens in the correct editor window for editing. So if you want to tweak something fast, you do not have to search through folders in the content browser. Then there is Save Current Level. The hotkey for this is Ctrl+S, and you should really get used to pressing it regularly. Unreal Engine can sometimes crash unexpectedly, so saving often protects your work. There is also Save Current Level As, which lets you save your current level under a new name, perfect if you want to create a backup version or try out changes without losing your original map. Save All saves not only the current level but everything else you have changed in the project at once. So all open levels, blueprints, materials, and other assets are saved in one click. When you change something in a level or an asset, Unreal shows a small indicator at the bottom with a list of all unsaved files. If you click on that list, you can review which files are not saved yet and then either save all or just pick specific ones to save. Then there is Import into Level. This option lets you bring external assets like 3D models or textures directly into your level and place them right away. It is a fast way to add new content without manually dragging files into your project folders. Export All or Export Selected lets you save out all or selected assets from your level to use them elsewhere. For example, if you want to share models or scenes with another project or artist. At the bottom of the File menu, you can create a new project or open an existing one. There is also Zip Project. This packs your whole project folder into a single zip file. It is really useful for backing up, sharing your work with teammates, or moving the project to another computer safely. And finally, Exit simply closes the engine when you are done working for the day. Next, let us look at the Edit menu and the History section inside it. First, there is Undo Movement. If you click this, your last action will be undone, whether you moved an object, changed a setting, or did anything else in the editor. You can click it multiple times to step back through your whole editing history until you reach the point you want. Redo does the opposite. If you have undone something, Redo will restore it exactly as it was. This is helpful if you undo too far and want to bring your changes back. Undo History shows you a full list of all actions you have done in the current session. You can click on any entry in this list to jump straight back to that specific point in your work. It is a quick way to rewind your steps without having to press undo again and again. Next is the Edit section. Cut removes the selected object or content and puts it on your clipboard so you can paste it somewhere else. Copy copies your selection to the clipboard without removing it. Paste places whatever you have on the clipboard back into your level. Duplicate makes a direct copy of the selected object in place, and Delete simply removes it from the level. All these actions have quick shortcuts to speed up your work. For example, if you select an object in the level and press Ctrl+C to copy it, then Ctrl+V to paste, the object appears at the exact same transform position as the original. You can then pull it away in the viewport to see the duplicate clearly. If you press Ctrl+V again, another copy appears at the same spot, so you can paste as many as you need. If you press Ctrl+X, you cut the object, which removes it from the level but keeps it ready to paste somewhere else. You can also hold Ctrl and click on multiple objects to select them as a group. Then press Ctrl+X to cut them and Ctrl+V to paste them back together wherever you want in the level. A quick tip: if you hold down the Alt key and then drag, for example, the green arrow of the gizmo, Unreal automatically duplicates the selected object and moves the copy at the same time. This is a super fast way to make extra copies while staying in your flow. Now let us select all 4 ramps. Hold down Ctrl and click each one to add them to your selection, then press the Delete key. This instantly removes all selected ramps from the level in one step. If you select any object and press Ctrl+D, it duplicates that object immediately. You will notice the duplicate is slightly offset in position. That little shift shows you clearly that the copy was created and is ready to move or place where you need it. And the same works for multiple selected objects too. Just select as many as you want, hit Ctrl+D, and Unreal duplicates the entire group, keeping everything neatly together so you can move or adjust them as one block. Next is the configuration section in the Edit menu. Here you can open the editor preferences. This panel lets you adjust all the settings that affect only how the Unreal Engine editor itself behaves. Things like interface layout, navigation controls, viewport behavior, and shortcuts. These settings do not change your actual project or game. They only change how you work inside the editor. I will make a separate video later where we will go through the most useful editor preferences step by step and set them up in a way that really helps you work faster and stay organized. Next is the project settings. This section is really important because it controls everything that defines how your entire project works, from input settings to rendering, physics, networking, and packaging for different platforms. No matter how small or big your game is, you will always end up here sooner or later. Sooner or later, you will need to tweak or check something in the project settings to make sure your game runs and behaves the way you want. For example, here you can set up your gameplay tags. These help you organize and manage things like abilities, attributes, or interaction rules in a clean and scalable way. Another important part is maps and modes. This is where you define which level should load by default when you start the game and which game mode should be used, so your project always opens with the right settings. I will make a separate video later that takes you through the most important project settings step by step, so you know exactly what to adjust and when to come back here. Last in this section are the plugins. Plugins are add-ons that extend Unreal Engine with extra tools and features that are not active by default. They make your project more powerful by adding new systems, workflows, or editor helpers that you can turn on when you need them, so you keep your engine clean and only load what you really use. For example, if we want to use the Pose Search plugin for advanced animation systems, we can just type Pose Search in the search bar here, tick the checkbox to enable it, and then the editor needs to restart to activate the plugin properly. You can also use the Add button here to create your own custom plugins if you want to build reusable systems for your projects or share tools with your team. We will skip the Windows menu for now and move on to Tools. The Tools menu gives you quick access to project-wide utilities like creating new assets or generating code. One important option here is New C++ class. With this, you can add a new C++ class to your project. This is how you can expand a blueprint-only project later with C++ code if you need more advanced logic or custom systems that are not practical in pure blueprints. The Tools bar is there to give you quick access to some really helpful project-wide actions and utilities. You will not use every option right away, but it is good to know what is here because it can save you a lot of time, especially as your project grows. One tool you will probably use often at the beginning is the Blueprint Debugger. This lets you pick any blueprint in your project and watch exactly what happens inside it while your game is running. You can see which nodes are being executed, what values variables have at any moment, and whether your logic works the way you expect. This is extremely useful for finding bugs or understanding why something does not work the way you planned. Instead of guessing, you see exactly what is happening live in the game. Another important part is if you are using a revision control system like Perforce or Git. Here, under View Changes, you can see all the files that have changed since your last commit. This helps you keep track of what you have modified, so you do not accidentally lose work or overwrite things when working with a team. You can check which blueprints, levels, or assets were edited, and make sure everything is saved and ready to commit to your version control system. Next is the Build menu. The Build menu is where you prepare parts of your project for final use. For example, you can build lighting to bake all dynamic and static lights into light maps, which makes your level render faster and look more realistic. The Build menu pulls everything together and updates all systems that need to be calculated and saved, so your level runs smoothly and looks polished when you hit play. We click on Map Check once and you will see that the message log opens at the bottom of the editor. Map Check scans your level for common issues, like missing references, overlapping geometry, or actors that are not set up correctly. It helps you catch problems early before they break your game or cause unexpected bugs when you run it. After running Map Check, the message log opens and shows us that the check is complete with 0 errors, which means our level is clean for now. The message log lists all warnings, errors, and info messages Unreal finds during the check. You can click any entry in this list and Unreal will automatically highlight the exact object in your level that needs fixing. This makes it really easy to jump straight to the problem spot and sort it out immediately, which saves you a lot of time and keeps your project stable and tidy as it grows. At the beginning, this build menu is not really something you need to worry about. It becomes more relevant later when you work with lighting, AI navigation, and final polish tasks for your levels. Next, let us check out the Select menu. This menu gives you tools to manage your selection in the level more efficiently. For example, if you click Select All, Unreal selects every single object in your current level at once. The shortcut for this is Ctrl+A if you want to deselect everything again. You just press Escape. This clears your selection immediately. In practice, selecting all objects at once is something you rarely need, but it is good to know it is there. Now, if we pick a few objects in the level and then click Invert Selection, Unreal flips your selection. All unselected objects become selected, and the ones you had selected before are now deselected. This can be really handy if you want to quickly select everything except what you just had marked. Then there is the Hierarchy section in the Select menu. This part lets you select objects based on their parent or child relationships in the outliner. For example, you can pick a parent actor and quickly select all its attached child actors too. Really helpful when working with grouped objects or complex setups like modular buildings. There are also extra selection helpers here, like lights. If you click Lights, Unreal will instantly select every light in your level, so you can adjust all your lighting actors at once or move them together if needed. This saves a lot of time when managing bigger scenes with many light sources spread around. So all these tools in the Select menu are about making your selection workflow faster and cleaner. You will not need them every day, but it is good to know they exist for those moments when they really save you clicks. Next, we select an object and check out the Actor menu. This menu gives you quick options related to the specific object you have selected. Just simple actions to manage or edit that actor. For example, you can click Browse to Asset. This jumps straight to the original asset in the content browser, so you instantly see where the mesh or asset is stored and can manage or replace it easily. You get this same actor menu when you right-click directly on the object in the viewport. This right-click actor menu gives you all the same options, because they are directly linked to what you currently have selected, so you can edit, replace, or manage it quickly without searching through other windows. If you click Edit SM_ramp, the mesh editor window opens. This lets you see and adjust properties of the static mesh itself, like materials, collisions, or LODs, so you can tweak details and see the results directly in your level. Finally, the Help menu. The Help menu gives you quick links to Unreal Engine's official documentation, tutorials, support resources, and community pages. If you ever get stuck or want to learn more about a feature, this is a good place to find guides and answers right from inside the editor. As already mentioned, we will cover the Windows menu a bit later. For now, let us focus on the toolbar down here. First, we have the Save button. This is your best friend while working. Always hit it to save your progress again and again. It is always better to save one time too many than to risk losing work. When you click it, it saves the currently opened file, for example, your level, directly to disk. Next is Browse to the associated file. In this case, if you click it, Unreal takes you straight to the file for the currently opened level in the content browser. This button works just like the Save button, it is always context-based. So whatever file or asset you have open, this button will find it for you instantly so you do not waste time searching through folders. Next, let us look at the modes. In Unreal Engine 5.6, we have 8 different modes you can switch between, depending on what you want to do in your level. The Selection mode is the current active mode. In this mode, you can select, move, rotate, and scale any object in your scene. This is the default mode you will use most of the time when placing props, setting up gameplay elements, or arranging your level layout. The next mode is Landscape. When you switch to Landscape mode, you enter the toolset for creating and editing large outdoor terrains. You can sculpt hills, carve valleys, paint textures like grass or sand, and shape your environment naturally. You will also see that the grid changes. It often appears green to show you are now working with the terrain system instead of regular static meshes. This makes it easy to know you are editing the landscape and not accidentally moving other objects around. Landscape mode is powerful for open-world maps, outdoor levels, or any scene that needs realistic ground shapes and layers. Next is foliage mode. This mode lets you quickly paint natural details like grass, bushes, trees, or rocks onto your landscape or any other surface in your level. Instead of placing each plant by hand, you can select multiple foliage assets, adjust settings like density or scale variation, and simply brush them onto the terrain. This is super efficient for covering large areas with realistic vegetation and adding life to your scenes without spending hours on manual placement. Then we have mesh paint mode. Mesh paint allows you to paint directly on the surface of a static mesh. For example, you can blend different materials on a single mesh, add dirt, wear, or other layered effects without needing to create extra textures in an external program. It is a powerful way to add variation and realism to your props or environments right inside Unreal. Another mode is modeling. The modeling mode gives you a set of built-in tools to make small edits to your meshes directly in the engine. It is not a full replacement for 3D modeling software like Blender or Maya, but it is great for quick adjustments, for example, fixing geometry, tweaking details, or setting the pivot point of a mesh to make placement easier. These small changes save time and mean you do not always have to go back to an external tool for minor fixes. The next mode is fracture. Fracture mode is used for creating destructible meshes. You can break apart static meshes into pieces and define how they should react when hit by forces or collisions in the game. This is really useful for making breakable walls, shattering props, or adding realistic destruction effects without needing extra tools. I will make a dedicated video on fracture later because it has a lot of options and is super powerful when used correctly. Then we have brush editing. Brush editing mode is for working with BSP geometry, also called brushes. These are simple shapes like boxes or cylinders that you can use to block out your level layouts quickly. In this mode, you can adjust faces, vertices, and edges to shape rooms, hallways, or prototype structures before replacing them with detailed static meshes. It is a classic way to build and test level flow in the early stages of your map design. Lastly, there is animation mode. This mode gives you tools to preview and adjust animations directly in the level, like setting up skeletal meshes, testing animation sequences, or checking blend spaces. I have not really used this mode myself yet, so I cannot say much about it right now, but it is good to know it is here when you start working more deeply with character animations. And that covers all the main modes for now, so you have a rough idea of what is possible and where to find the right tools when you need them. Next is the Quickly Add to Project dropdown. This menu gives you shortcuts to bring new content or tools into your project with just a few clicks. No need to dig through the content browser manually. The first option is Import Content. This lets you quickly bring in external files like 3D models, textures, audio, or animations straight into your project folder and have them ready to use in your level right away. Then we have Quixel Bridge. This connects your project directly to the Quixel Megascans library, a huge collection of high-quality scanned assets like rocks, surfaces, plants, and props. You can browse, download, and drag these assets straight into your scene without leaving the editor. We will actually use Quixel Bridge later in the video, but for now, it is good to see where it lives so you know how to open it when you need realistic, high-detail assets for your world. Next is the Fab option. Fab is now built into Unreal Engine as a plugin, giving you direct access to the new Fab Store right inside your project. The Fab Store in Unreal Engine 5.6 is the evolution of the old Marketplace and Quixel Bridge combined. Here you can find thousands of assets, from 3D models and materials to sounds and animations, all in one place. You can search, browse, and directly drag high-quality content into your level to speed up your workflow and bring your scenes to life faster. We will use Fab later in the video to add assets to our project, but for now, it is good for you to know where it is and that you can reach it anytime through this plugin. Then we have the Content Browser actions. These are quick shortcuts related to the content browser itself, so you can open new content browser tabs, dock or undock them, or jump straight to specific folders to organize and manage your assets faster. Next is the Place Actors section. This is where you can quickly drag different types of actors and elements directly into your level. Under Basic, you will find things like generic actors, characters, pawns, or trigger box objects. These are the foundation for building gameplay or setting up logic, but for now, they are not so important for us yet. Then there is the lights section, which lets you drop in different light types like point lights or spotlights to light up your scene. The shapes section is a great one for quick samples. Here you can drag in basic shapes like cubes, spheres, cones, or cylinders. Just click on any shape and it will be placed directly in your level. This is perfect for blocking out your map, testing scale, or setting up prototypes before you switch to detailed models later. It is basically a collection of all the actors you can spawn directly into your world. Under the All category, you will find the full list, everything from lights and shapes to cameras, volumes, and special gameplay actors. So if you ever need something specific, this is where you can find it quickly. At the bottom, there is also the recent section. This shows you the last actors you placed in your level, so you can grab them again without searching through the whole list. A small but super handy time saver. Then we have the Place Actors panel. This opens a panel on the left side of your editor. It works exactly the same way. It shows you the same categories and lists of actors, but as a fixed panel you can keep open while you work. So instead of using the top drop-down every time, you have the whole library docked and ready to drag and drop actors into your scene whenever you need them. To close this panel, just click the small blue arrow at the top left. This collapses the panel into a tab so it does not take up space. You can open or close it anytime depending on how you like to work. Next, we have the list of world blueprints available to the user. You will see this as the editor or creation icon. This gives you quick access to create or manage blueprint classes directly inside the editor. Here, for example, you can create a new empty blueprint class. This is how you build reusable logic or custom actors for your game. If you already have an actor selected in the world, you can use the Convert Selection to Blueprint Class option. When you click this, Unreal asks you to pick a creation method. For example, you could choose Child Actor. Once you confirm, a new blueprint is created that includes the selected actor as its base. I personally have not used this way much to make my blueprints, but it is definitely possible and can be handy when you want to turn a placed object into a reusable blueprint quickly without setting it up from scratch. You can also use this section to open the level blueprint directly. Many people do not even know that every level actually has its own blueprint. The level blueprint is where you can script logic that is tied specifically to this level, like triggers, events, or unique actions that only run here. You can also quickly adjust the game mode here using the same dropdown. This sets which game mode blueprint is linked to this level. It overrides the default game mode you may have set in the project settings and makes sure this specific map uses the correct rules, player character, HUD, and game logic. So in general, this dropdown is here to manage which global blueprint systems are connected to your level, like the level blueprint for map-specific events or the game mode to control your gameplay rules exactly how you need them for this map. Next is the sequencer dropdown. Here you can add a level sequence, which is basically a timeline that lets you create and control cinematic scenes, cutscenes, or any kind of scripted animation in your level. With a level sequence, you can animate actors, cameras, lights, and even gameplay events in a clear timeline, just like video editing, but in real-time 3D. You can also choose Add Level Sequence with Shots. This version sets up your sequence already organized with shot tracks, which is super handy for more complex cinematics. It helps you break your scene into multiple shots right away, so you can plan your camera cuts, angles, and transitions more easily while keeping everything clean and structured. Both options are powerful tools if you want to bring storytelling, cutscenes, or trailers directly into your Unreal Engine project. Next is the Play action. With the green Play button, you can start the game right inside the editor to test your level and see exactly how everything works in real time, just like the player will experience it. While you are playing, you can press Shift plus F1. This releases your mouse cursor from the game window, so you can click on other parts of the editor without stopping the game. Super useful for debugging or adjusting things while the game keeps running. You can also click here on Detach from Player, or press F8 as a shortcut. This stops the camera from following the player character and lets you fly freely through the world while the game continues in the background. It is perfect for checking what is happening elsewhere in your level while testing gameplay. There is also a pause button that freezes the game instantly. You can then step through your game frame by clicking the Next Frame button, really helpful for tracking down tricky bugs or checking animations in detail. When you want to jump back into your player character, Just click the Attach to Player button again, and your view snaps back to the game camera. Finally, the red Stop button, the little red rectangle, completely ends play mode and takes you back to the editor, so you can continue editing right away. Then we have Change Play Mode and Play Settings under these three dots. This gives you extra options to control how your game starts when you hit play. Just some quick ways to adjust your testing setup. By default, the game starts right in the selected viewport, so you play inside the editor window you are working in. But you can click New Editor Window, PI, which stands for Play in Editor. This launches your game in a separate window, which is super useful if you want to test full screen or see how things behave in an external view without messing with your main editor layout. Further down, there is the Net Mode setting. This lets you test multiplayer right inside the editor. For example, you can select Play as Client and set the number of players to 2. When you hit play, Unreal launches your game in 2 separate windows, so you can control each player individually and test how your multiplayer logic works in real time. It is really helpful for making sure your network features work exactly as they should, even before packaging your project. The last option here is Platforms. This section is all about deciding where and how you want to build and package your project for different target devices. For example, you can build your project directly for Windows here, or choose other platforms like Android, iOS or Mac, depending on what your project is set up for. This menu gives you quick access to start the packaging process, set up platform-specific settings, and make sure your game runs correctly on the hardware you plan to release it on. It is a simple but very important step when you are ready to share or test your project outside the editor. Then, up here on the top right, you see your current project name. If you hover your mouse over it, you can see extra info about your project, like the current Unreal Engine version you are using, the build configuration, and sometimes the project file path. This helps you quickly check which version you are working with, especially if you have multiple projects or engine installs on your system. Now, let us talk about the outliner. The outliner shows you a list of all objects in your level, organized by type and hierarchy. It is like a live folder structure for everything placed in your scene. Every actor, light, mesh, camera, and helper is listed here. You can select an object directly in the outliner, or pick something in the viewport. When you do that, Unreal automatically highlights it in the outliner too. So you always know exactly where your object sits in the scene structure. The outliner is like a clean, flexible hierarchy. The root point at the top is your level itself. Below that, you can create folders to group your objects. For example, here there is a lighting folder that holds all the light actors together. You can collapse or expand folders to keep things tidy and easy to navigate. If you select a folder, you can use the little eye icon on the left, the toggle visibility button, to hide or show everything inside that folder in the level at once. This is super handy for organizing your scene and turning parts of it on or off without deleting anything, so you can focus on specific areas while you work. If you select an object, hold Shift, and then click another object further down, you can select all objects in between at once, just like in a file explorer. This makes it really easy to grab multiple actors together. You can then toggle the visibility for all of them at the same time using the eye icon, which is super handy for organizing complex scenes. You can also use the search bar at the top of the outliner. For example, if you type cube, it instantly filters and shows you all objects with cube in their name, so you can find and manage them without scrolling through a long list. Up in the top right corner, there is also a small gear icon for settings. You will find this gear icon in pretty much every panel window in Unreal. It lets you customize how that panel looks and behaves. For the outliner, you can use it to expand or collapse all elements, change sorting, or adjust what details are shown. It is a great way to keep your workspace clear and tailored to how you like to work. You can also select multiple objects, right-click, and you will get the actor menu, with all the options that match the selected objects. For example, you can choose Replace selected actors with and swap them out for another actor, like replacing all selected meshes with a sphere in one click. If you want to undo this change, just press Ctrl+Z and everything goes back to how it was. Now I will delete all the extra actors we added and leave only the sphere. We will use this sphere to take a closer look at the Details panel. Every time you select a different object, the Details panel updates to show all the settings and properties specific to that object type. Here we have the sphere selected, and you can see in the details panel that the sphere instance is highlighted. It shows up as a static mesh component because that is what this object is made of. If you select another object in your level, the details panel updates immediately and shows you the settings for that specific object instead. So you always see exactly what you have selected, and you can adjust its properties right here without searching through other menus. As we mentioned earlier, here you see the transform section. Every actor in your scene has transform properties, location, rotation, and scale that control exactly where it sits in the world, how it is turned, and how big or small it appears. The details panel is your main place to tweak these values precisely and adjust any other settings or components connected to the selected actor. Every property in Unreal Engine usually has a small arrow on the right side, but this arrow only shows up if you have changed the default value. This is really helpful because it instantly shows you which settings have been customized, which is super important for understanding what has been modified in your scene or actor. If you click this arrow, it resets that property right back to its original default. In our case with the sphere, the location property is a vector with a default value of 0. If you press the F key while the actor is selected, the camera jumps straight to that actor, so you instantly fly to its position in the level. On this map, 0 is the origin point, so this is always your clean starting location. Since our sphere is sitting right at the origin, we need to drag it upward to see how this works. When we move the sphere up, you will see the Z position changes in the details panel, and the small reset arrow appears again. This shows you that the position is no longer at its default value. You can click the arrow anytime to snap it right back to 0 and return the actor to the exact origin point. Next example. Our scale value for this sphere is currently set to 1 by default. We can adjust it to any size we want, for example scale it up or down, and the mesh changes size in real time. If we then click the small arrow next to the scale value, it resets right back to its default of 1. So the sphere goes back to its original size immediately. The next important setting is mobility. Every actor in Unreal has a mobility setting that controls how it behaves in the level. There are 3 options: static, stationary, and movable. Static means the object never moves and can be fully baked into the level lighting for maximum performance. Stationary means it can change certain properties like light intensity but stays in place. Movable means the object can move, rotate, or animate freely at runtime. So we select our sphere, duplicate it once, and change the mobility of the new sphere to movable. Then we duplicate it a few more times so we have several spheres in the scene. Now we select just Sphere 6 and scroll down in the Details panel to the Physics section. This section contains all the physics-related settings for your actor, things like whether it should simulate physics, how heavy it is, how it reacts to collisions, and so on. We enable Simulate Physics, which tells Unreal to treat this sphere as a physical object that reacts to gravity and other forces. We also set the mass in kilograms to 109. Then we hit play. But wait a moment. I need to switch the play mode back to a single player so we can test this properly. Now, when we hit play, you can see that only Sphere 6 drops to the ground. This is because physics simulation is turned on and its mobility is set to movable, which lets the physics engine update its position during gameplay. The other spheres stay where they are because they do not have physics enabled or they are still set to static, so they cannot move at all during gameplay. If you run into Sphere 6, you will see it moves and reacts, because its mobility is set to movable and physics simulation is turned on. The physics engine calculates the impact and lets it roll or slide naturally. All the other spheres stay exactly where they are because they do not simulate physics and Unreal treats them as fixed parts of the level. This shows how important mobility and physics settings are when you want dynamic objects in your scene that players can push, collide with, or interact with in real time. We now select all the other 5 spheres and enable Simulate Physics for them too, setting the mass in kilograms to 100. This way, we apply the same physics settings to all of them at once. Next, we add Sphere 6 back to the selection so that all 6 spheres are now selected together. Since they all now share the same mobility and physics settings, they will all behave the same way in the scene. Here you can see an interesting detail in the Details panel. Because we have multiple objects selected that share the same properties, like simulate physics and mass, those show up with the exact values we set. But for any property where the selected objects have different values, like location, rotation, or scale, Unreal shows multiple values instead of a single number. This tells you that the selected objects do not all share the same value for that property. All our spheres now have the same physics behavior but still sit at different positions in the world, which is exactly why the location shows as multiple values. This helps you quickly understand which settings match across your selection and which do not, so you can adjust them all at once if you want. If we hit play now, all the spheres behave the same way. They fall down and react to gravity because we enabled simulate physics for all of them. When you run into them, they roll away naturally, showing that the physics settings and movable mobility work together. So with just one setting, we modified all spheres at once and made them dynamic. Now, if we select only the sphere on the right and change its mobility back from movable to static, then start play mode, you will see something important. Even though simulate physics is still enabled, the sphere stays frozen in the air. That is because static actors cannot move at runtime. Physics needs the object to be movable so the engine knows it is allowed to update its position. So if an actor is static, any physics simulation will simply be ignored and it will stay locked in place. Now we select Sphere 4 and you can see the static mesh section in the Details panel. This shows which mesh is used for this actor. If you click on the drop-down here, you get a list of all available meshes in your project, and you can swap the mesh instantly. For example, we can change the sphere to a cube and the actor updates in the level right away. Directly below that is the Materials section. Here you see which material is applied to the mesh's surface. A material controls the look of the object, its color, shine, or texture. If you click the drop-down, you can choose a different material. For example, change the cube's material to a bright red one so it stands out. We can also select another sphere and change its material too. For example, set it to silver or any other material you like. When we hit play now, everything still works the same, physics simulation stays active, and all our settings remain. We can even run into the cube, and it will react and simulate physics just like the other spheres. Only the mesh and material changed, but the behavior stays exactly how we set it up. We can also select something else from the level, like the green ramps for example. In the Details panel, under the Materials section, you will see which material is applied to the ramps. Here you can click the small magnifying glass icon, Browse to jump directly to that material in the content browser. When we open the material, we see it as a material instance. For this instance, for example, a base color property has been set up. We can adjust this color right here, changing it to a darker gray or any other shade we want. Then we just click Save and close the material editor. Now back in the level, you will see that all objects using this material automatically update to the new color, because they all share the same material instance. This makes it super easy to change the look of multiple assets at once without having to edit each one manually. Now we select the red cube and click the Reset to Default icon next to the static mesh in the Details panel. You will see it changes to none, which means the actor no longer has a mesh assigned. The object becomes invisible in the level because there is nothing to render. No mesh means nothing to show. Since no mesh is set, the Materials section also disappears automatically, because without a mesh there is nothing to apply a material to. If we press Ctrl+Z to undo, the mesh is restored, and right away the Materials section comes back too, because now the actor has a valid mesh again that can display a material. We can do the same with the material itself. If you reset the material to its default, Unreal applies the default world grid material. This is a simple gray grid pattern that helps you see the shape of your mesh. It is used whenever you have not assigned a custom material yet, so you always see something in the viewport instead of an empty object. Every actor has countless settings and options, but do not worry, you will learn them step by step as you work more in Unreal. It is impossible to memorize all details right from the start, but seeing them once already helps you recognize them later when you need them. Lastly, let me show you the collision section. Unreal offers a wide range of collision presets for different use cases. For example, we can change the preset from Physics Actor to No Collision. This means the object no longer blocks anything, It does not collide with the player, other actors, or physics. If we hit play now, you will see that the cube stays floating in the air and we can walk straight through it. There is no collision anymore, so it acts like it does not exist physically in the world, even though it is still visible. If we stop play mode now, we get an error message saying something like, invalid simulate option. Cube is set to simulate physics but collision enabled is incompatible. This means Unreal is warning us that physics simulation needs collision to work correctly, because without collision, the physics engine has nothing to push against or detect. So if an object is set to simulate physics but has no collision, it cannot react properly, it will just break the expected behavior. This is a good reminder that physics and collision always work together. If you want an object to move and interact physically, it needs valid collision turned on. Earlier we skipped the Windows menu, but now is the perfect moment to explain it because it fits well with what we just saw. If you accidentally close some panels, like the outliner, the details panel, or the world settings, many beginners start to panic because they do not know how to get them back. That is exactly what the Windows menu at the top is for. You can open the Windows menu and re-enable any panel you need. For example, you can turn the outliner back on, reopen the details panel, or bring back the world settings, plus any other panels you might miss while working. So whenever you lose a window, just check under Window to show it again, quick and easy. You can also open the message log here, the same one we saw earlier that showed us the error about the invalid physics setup. Another helpful tool here is the output log. The output log shows you all kinds of system messages, warnings, and prints from your game while it runs, really useful for debugging or tracking what happens behind the scenes. You will also find shortcuts here for Fab and Quixel Bridge, so you can launch them directly from the Windows menu too. This shows you there is often more than one way to open important tools and panels in Unreal. Lastly, there is the Layout section. Here you can save, load, or reset your editor layout. So if you have moved panels around or closed things by accident, you can always reset to the default layout or load a custom one you saved, so your workspace stays exactly how you like it. For example, you can switch here to the UE4 Classic layout. You will see the layout looks very similar, but it also brings back the Place Actors panel on the left side, the one we looked at earlier. If you want, you can always switch back to the default editor layout. But sometimes when you do that, you might notice that parts of your layout are missing, like here, the content browser at the bottom is gone. So you just go to the Windows menu, find Content Browser, and click Content Browser 1, and it appears again at the bottom of your workspace. If you want, you can even open Content Browser 2 as an extra window. This new content browser appears as a floating panel that you can move anywhere on your screen. If you drag it by its tab, you can dock it into other tab areas, for example, next to the outliner, so you can switch between them easily. This flexibility lets you customize your entire layout exactly the way you like to work. Arrange panels, tabs, and tools so everything you need is right where you want it. Now, let us take a closer look at the content browser itself. The content browser is designed in a simple and familiar way, just like you know it from common operating systems. You can expand or collapse folders here or open them directly through the hierarchy. The content folder is the main folder in Unreal Engine and contains all your project's assets. On the right side, you can navigate through your folders just like you would in the Windows Explorer, which makes managing files very intuitive. In the top left corner, there is a Favorites section that you can expand to quickly access frequently used folders. When you right-click on a folder, you get a context menu with useful options. This context menu gives you quick actions like renaming, duplicating, or deleting, and it also offers bulk operations for handling multiple files at once. You also have various folder options, for example showing in Explorer. What we do here is add the folder to Favorites. This pins the folder to your favorite list so you can reach it directly on the left side under Favorites. It is a small but powerful feature, especially when working with larger projects that have many assets. We open the content folder and take a closer look at some additional features. Here we have an Add button, which is a quick way to create new assets or folders right inside the currently selected folder. At the very top, you see options like Import to Current Folder, which lets you bring in files from your computer directly into this folder. Below that is Add Feature or Content Pack. We will use this a bit later to add ready-made content to our project. You can also create a new folder here in the active folder, in our case the content folder. Right under that, you have all the options to add blueprints, levels, materials, and many other asset types you might need. There are a lot of options here, but do not worry, you will learn each part step by step when the time comes. Do not let the list overwhelm you. If you right-click anywhere inside the content browser without selecting any asset, you get exactly the same menu. This is the default context menu for empty space and works just like the one we saw before with folders, so it always shows options based on what you click on. Now, with the content folder selected, we right-click and choose Add Feature or Content Pack. This lets us easily add pre-made systems or example content. Here we choose Content in the top right and add the Starter Pack. The Starter Pack gives you a set of basic example assets like materials, levels, and blueprints to experiment with. We can now see that a new folder named Starter Content appears in our content browser. Opening it reveals more folders for materials, levels, and more. What is interesting for us now is the Props folder, where you will find sample static meshes you can use for testing and building your scenes. On the right side, next to the gear icon, you can adjust the view type of the content browser. For example, you can switch between a list or a column view, which helps you manage how your assets are displayed and organized. There are many other settings here to customize how the content browser looks and behaves, so you can adjust it to fit your workflow. One feature I want to highlight is the thumbnail size. Here you can directly select how big or small the asset previews should appear. This is useful when you want to see more detail or simply fit more items into view. You can also hold down the Control key and scroll your mouse wheel up or down to adjust the thumbnail size quickly. Next, let's look at the filters, which are often very helpful when working with many assets. This is the filter icon here. When you click it, a menu opens where you can choose exactly what you want to filter for. For example, we want to filter all static meshes. Once we activate it, the filter appears on the left in the list. Now if we open the content folder, we see all static meshes recursively, so all the way through the folder tree. If we open the starter content folder, we only see the meshes inside this folder. And if we open the props folder, we see only the static meshes inside props. You can toggle filters on and off individually, and you can also combine multiple filters to narrow down your search even more. If we disable the filter in the menu, it disappears from the list as well. Now let's pick a spot in the map for the next step. We can grab individual static meshes from the content browser, for example the chair, and simply drag it into the level. We do the same with the bench. There is also a door and the bush, where the thumbnail is currently broken, but yes, it is a bush. Next, we have a table, and on this table we can easily drag the statue and place it right on top. In the bottom right, you will see that we now have 7 unsaved files. You can click Save All in the content browser, which brings up a window showing what is not saved yet. Simply click Save selected to save them. You can also navigate through folders using this bar here by clicking on the folder names. If you click the small arrow, it will show all folders inside the previous one so you can open them directly. For example, we can also drag the character we want to play as into the level, which we find under Character, Mannequins, Meshes. Just grab it and place it into the level. We place him twice in the level just for fun. When we press play now, we can walk around and see the objects we placed. Some of them have collision enabled by default, others do not, but this shows you the basic workflow of how actors work in Unreal Engine. A world is built entirely from actors, and this is the core mechanic you will use to create your levels. If we stop play mode, we still see the invalid simulate object error. Let's fix this quickly. We select the red cube object. Then in the Details panel we search for the Collision Presets property and change it from No Collision back to Physics Actor. If we now start play mode again, we see the cube falling down as expected. When we stop play mode, there is no more error. So it is important to understand that the content browser is the central folder that holds your entire project. If we now open the Maps folder inside Starter Content, we find several predefined levels here. Let's open the Starter map. This is an example level from the starter pack with surfaces, props, and various materials to demonstrate basic features. When we start play mode, we can see that some objects at the top are falling down with physics simulation. There are also particle effects and material examples placed in the scene. You can move around freely here and take a closer look at how everything is set up. All these sample materials can be used perfectly in your own game, so it is definitely worth taking a closer look here. If you press F8, you detach the character and can move freely around the map, just like we learned earlier. We can go over to the objects that fell down. While the game is running, we can select them and push them around the scene. Once you release them, they continue reacting with physics and collision as expected. This golden sphere will probably never be seen again because it will now keep falling endlessly through the world. Every time you grab and release a sphere like this, it will follow the physics simulation just as expected. Let's drop one sphere here so it lands properly on the platform. What you can see here is that if you try to scale the sphere while in gameplay mode, it does not work. Now we attach back to our character and run over to this golden sphere. We can push it, and it will fall and react with physics again. So even while play mode is running, you can still work almost as usual in the world and interact with objects directly. Now let's switch back to our previous level by opening the File menu and using Recent Levels to select our old LVL third-person level again. Take a look at the toggle lock in the content browser. When you activate this, it locks the current view of the content browser. So if you now click something like Browse to File at the top, this locked content browser stays exactly as it is and Unreal Engine opens the content drawer instead. This helps you keep your main content browser focused on your chosen folder while quickly browsing other assets in parallel. We can also close the main content browser, and every time you press Ctrl+space, the content drawer opens. You can also open it directly using the button down here on the bottom left. If you want to keep it permanently visible, you can click Dock in Layout. This pins the content drawer into your main editor layout so it stays open just like the normal content browser. Even when it is docked, you can still use Ctrl+space to open the content drawer at any time, and it always keeps the last open state. So if you open a folder, close the content drawer, and open it again, it will show exactly the same folder as before. Let's take a closer look at the assets now. Right-click or click on Add to open the Asset Creation menu. Here you find pretty much all the main asset types you can create in Unreal Engine. There are a lot of options, but you will learn step by step when and why you need each one. Depending on your project, you will always need different types. For animations, for example, you would create an animation blueprint. Most of the time, though, you will be creating blueprint classes, because they let you build game logic, reusable objects, and interactive actors that make up your gameplay. You can also create levels, level sequences, materials, and much more from here. Now let's look at the assets that come with the starter content pack. We start in the Architecture folder. Here we have a list of so-called static meshes like floor, pillar, walls, and walls with door. Static meshes are 3D models that do not have their own built-in animation or logic. They are used to build the visible geometry of your world like floors, walls, props, or any other physical objects. In the content browser, you can see for each asset its thumbnail, its name, and its type, here, static mesh. Additionally, every asset type has a small colored line under the thumbnail. For static meshes, it is turquoise. This color coding helps you quickly identify what kind of asset you are looking at while browsing through your project. Right-click on a static mesh and you will see the context menu that is specific to static meshes. Most parts of the menu look the same as for other assets, but at the top you get a special static mesh actions section where you can do actions related to meshes, like converting the static mesh to a skeletal mesh or enabling nanite, which optimizes high poly meshes for better performance. Next, let's look at the audio folder. Here you will find audio files like sound waves and sound cues. A sound wave is a raw audio file, while a sound cue is a more advanced asset that can combine multiple sounds, add effects, or control how the sound behaves in the game. You can recognize them by their unique thumbnails. Sound waves usually have a waveform icon, while sound cues have a small speaker symbol. Then let's open the Blueprints folder. Here you see blueprint classes from the starter content pack, like the blueprint ceiling light. This blueprint is a simple example of a light that includes specific functions, for example to switch on or off or control the light behavior in your scene. After that, we have the HDRI folder with a single texture cube. A texture cube is a special texture type used for environment reflections or skylighting. If you look at the maps from the starter content pack, you will find this texture used to light the scene with realistic reflections. Then we have the maps folder containing different levels. Earlier, we looked at the starter map as an example. Levels are displayed with an orange icon so you can quickly spot them in the content browser. You will also see this orange icon at the top left of the editor tab when a level is opened, making it easy to keep track of which level you are currently working on. Next, the materials folder. We see a lot of materials here, and you will notice that each material asset starts with M_. This naming convention helps you immediately recognize that this file is a material, which keeps your project organized and clear. Right away, we can grab the floor walnut material and drag it directly into the viewport onto the floor. This automatically applies the material to that object. Now, if we select the floor in the viewport, we can see in the details panel that the material has changed to floor walnut. You can also grab any other material from the content browser and drag it directly onto the material slot in the details panel. The object will instantly update with the new material. If you want to revert it, you can use the small reset arrow next to the slot, and it will go back to using the default material. You can pick another material and apply it again the same way. You can drag materials onto any object in the viewport, like the bench for example. As you can see, it is really easy to change the materials on your objects manually like this. And if you want to undo any change, just use Ctrl+Z to quickly step back. We will take a closer look at the materials in a moment, but first let's move on to the particles folder. Here we have a few sample Cascade particle systems. Cascade is Unreal Engine's older particle system for creating effects like explosions, smoke, or fire. You can drag and drop these directly into your level as well. For example, if you drop an explosion into the scene, it will play once when it is spawned. Some of these particles are set up to loop all the time, like fire or smoke effects, so they keep playing continuously in the level. Cascade lets you combine different emitters, like sparks, smoke, or light, to create complex effects for your game. Here we have a fire particle effect, and we can drop a steam-lit particle as well and mix them together to get a combination of fire and smoke. Of course, this does not really make sense in a realistic setup, but it is just a very simple and quick example to show you that you can combine different Cascade particles in your level. This way you can experiment with effects and see how they behave when layered together, even if this quick demo is not practical for a real game yet. Next, we have the props folder, which contains the static meshes we used earlier, like the chair, bench, and other objects. Then there is the shapes folder, which includes simple static mesh shapes like cubes, spheres, and cones that you have already seen. The last one is the textures folder. Here you find a lot of textures that are used by the materials we looked at before. A texture is a 2D image that gives a material its detailed look, like wood grain, metal scratches, or stone surfaces. Textures add color and surface detail to your models and are a core part of how materials appear in your game. Now let's look at a few small everyday tasks you often do with the content browser. For example, let's select the SM_couch in the level. In the details panel or anywhere you see this browse to magnifying glass icon, you can click it to quickly navigate to the asset in the content browser. This is really handy if you want to find the file for a selected actor or, for example, locate the material that is defined on it. It helps you keep track of where your assets are stored. We now navigate back to our SM_couch asset folder. This takes us right back to the original location where the SM_couch is stored. Next, we create a new folder named Forceit. Then we grab the SM_chair and move it into this new folder. When you do this, you get a small menu with options, and if you choose Advanced Copy here, you can decide whether to move, duplicate, or rename the asset while copying. This is helpful if you want more control over how the asset is organized. If we select Move here, the chair will be moved completely to the new folder. Now we drag the SM_couch and drop it into the Forceit folder as well, but this time we choose Copy here. This creates a duplicate of the couch in the new folder while keeping the original in place. Now we see that the chair has been moved to the Forset folder, and the couch is still in its original location. If we open the Forset folder, we find the chair and the new copied sm_couch asset. You will notice a small star icon on the couch thumbnail. This means the file is currently not saved yet. If you press Ctrl+S, it will be saved and the star will disappear. If we want to move the chair back to its original place, we can simply drag it using the left hierarchy folder structure. We drop the sm_chair onto the props folder to move the chair back where it was before. If we open the props folder now, we can see the chair is right back in its original location. Next, we go back into the Forset folder and drop the sm_couch into the level without saving. If we now want to delete the sm_couch file, we right-click on it and choose Delete. We get a delete asset prompt saying this file has no asset references but does have a memory reference. Even though we dropped it into the level, it does not show an asset reference directly yet because we did not save the level, so the engine does not officially register the link to the file. We cancel this and click Save All to save all files. Now if we try to delete the asset again, we see that it now shows both a memory reference and an asset reference. This means the asset is actually used somewhere. In our case, it is used in the level and is saved now. If you see an asset reference when trying to delete, it is always recommended to remove those references first or replace the asset with another one. Here, we select Replace References, pick the sm_chair as the replacement, and confirm it. This automatically swaps out the sm_couch in the level with our selected chair. After confirming, we save it, and now the couch asset is completely deleted from the content browser, while in the level it was replaced by the chair, keeping the scene intact without missing references. Now we switch back to the props folder and delete our Forset folder. When you do this, you get a prompt that checks first if the folder can really be deleted safely or if there are still references somewhere that would break if you remove it. Next, let's look at the rename process, because this has a few special details. We rename the sm_chair to sm_chair_new. That works without any issues. But now, if we try to rename another asset to sm_chair, we see an error saying an asset with that name already exists at this location. This happens because when you rename an asset in Unreal Engine, the old file path still exists temporarily as a hidden reference file, called a redirector. The redirector keeps track of the old name so other assets that still point to the old name do not break immediately. To solve this, we click on the props folder and select Fix Up Redirectors in folder. This prompt goes through the folder, finds all old redirectors, and updates or removes them by pointing everything to the current asset names. This clears up leftover references so you can reuse names safely and keep your project clean without broken links. We were now able to rename sm_door to chair without any problem. But if we want to rename it back to sm_door, we get the same error again. This happens because there is still a redirector left for the old sm_door name that blocks us from using it directly. So once again, we have to run Fix Up Redirectors to clean up those leftover references. Only then can we use the sm_door name again. Now, if we try to rename sm_chair_new back to sm_chair, we run into the same issue, because the redirector for door is still sitting there. So we run Fix Up Redirectors again to remove this leftover link. After that, we can rename sm_chair_new back to sm_chair with no problems. So always keep an eye on this. If you try to give a file a name but it does not exist in the folder, in 99% of all cases it is because of leftover redirectors. These hidden files hold the old paths to keep references working, so always remember to fix them up regularly to avoid naming conflicts and keep your project structure clean. Let us take a look at blueprints next, but before we do that, we want to set up a small example with a lamp and light source. First, we drag the sm_lamp ceiling mesh into the world. This gives us a simple ceiling lamp model. Then we add a point light to the level. A point light emits light equally in all directions from a single point, like a light bulb, and is perfect for creating soft, natural light around props like lamps. Next, we try to position the point light underneath the ceiling lamp so it looks like the lamp is really glowing. Now we have a simple ceiling light setup that actually lights up the room. To keep things organized, we can drag the point light in the outliner and drop it onto the SM_lamp ceiling. This makes the light a child of the lamp mesh. Now, when we move or rotate the lamp in the level, the light stays attached and moves along with it, so you always keep your lamp and its light source together. So far, so good. This gives us a clean, simple setup that shows how meshes and lights can be grouped to work as one. If we select the point light, we can also change the intensity, which sets how bright the light shines. We can adjust its attenuation radius in the Details panel. This controls how far the light reaches out into the scene. The larger the radius, the bigger the area that gets illuminated. When you build just one light setup like this, that is fine. But if you duplicate it, now you have two lamps. Any change you want to make later means you have to select each lamp and update it by hand. That quickly becomes a huge hassle if you have 50 or 100 lamps placed in your level. So we delete this setup, because this is exactly where blueprints come in. In the Starter Contents Blueprints folder, you will find the Blueprint Ceiling Light. If you drag this into your level, you get a ready-made ceiling lamp with a light source already set up inside the blueprint. If you check the Details panel for this blueprint actor, you will see a new custom category named Light with 3 properties. One property is Brightness. This controls the intensity of the light directly, so you can make it brighter or dimmer with one click. The second is Color, which lets you change the color of the light without digging into the light component itself. And the third is Source Radius. This controls the size of the light source, which affects how soft or hard the light looks when it hits surfaces. Now if you duplicate this blueprint lamp, you will see that each new copy starts with the default values again. Only the first lamp keeps the custom values you change. So all new instances stay clean and consistent. We can double-click the blueprint in the content browser to open it. This opens a new tab. You can grab this tab and drag it up to your Open Level tab to dock them together. Now you can easily switch back and forth between your level and the blueprint. Inside the blueprint, you see the same light section in the Details panel with those 3 properties. These are variables that were created inside the blueprint itself, grouped under the light category. They are exposed so you can adjust them for each lamp instance in your level, without changing the blueprint structure. This is the power of blueprints. They store setup and logic once and expose only what you need to tweak for every placed copy, saving you tons of manual work later on. Up here on the top left is the Components panel. This shows you all parts that make up your blueprint, like meshes, lights, or other components. If we select the blueprint ceiling light itself, we see its construction script as a graph in the main window. Inside this graph, you can hold the right mouse button to pan around freely, and use the mouse wheel to zoom in and out, just like in the main editor. The construction script is special because it runs every time you place or update this blueprint in the level. It is where you set up or adjust anything that needs to be applied automatically when the actor is built in the scene. In this example, you see 3 function calls. These set the default values from the blueprint's variables to the target point light component. Specifically, they apply the brightness, color, and source radius values to the light. These 3 variables are exactly the same properties you see in the Details panel when you select this blueprint in the viewport. On the right, you see the same Details panel you know from the level, except the Transform section is missing here. That is because the transform, location, rotation, scale is handled in the level itself when you place the blueprint, not inside the blueprint asset. So here, you only adjust the properties that belong to the blueprint's logic. Here you can set a default value for brightness. Before, we saw it was 1700. Now we change it to 2500. After that, we click Compile. This applies all changes and makes sure the blueprint logic is updated correctly. Always compile your blueprint to activate your edits. Then save it and switch back to the level. Now you see that the 3 lamps on the left shine brighter, because they automatically use the updated default value. The first lamp on the right still has the custom brightness we changed before. If you select the other 3 lamps and look at their brightness, you see they now use the new default of 2500 instead of the old 1700. So with one small change, we updated all lamps in the level at once. For the blue lamp, if you click the reset arrow next to brightness, it resets back to the current default, which is now 2500. Earlier, the default was 1700, but since we changed it in the blueprint, the new base value is 2500, and that is what the reset uses now. In the same way, we can also change the default value for the color. We set it to green, click compile and save, and go back to the level view. And you see the color has changed to green for all lamps except the blue one, because we had overridden its default value before. If we click the reset arrow for the blue lamp's color, it also switches to the new default green color, because the reset always uses the blueprint's current default. Back in the blueprint, we also have the event graph. Right now, it is empty, but the event graph is where you add the logic that runs while your game is playing. Here you connect nodes to create gameplay functions, like triggering animations, responding to player input, or handling interactions. We will build a simple example for this later. Then there is the Viewport tab in the blueprint. This shows you a 3D preview of your blueprint's components. Here you can see our SM_lamp_ceiling and the point light. The viewport has the same controls and settings we saw at the start of the video. You have the gizmo for moving, rotating, or scaling parts, plus the same perspective and snapping options. This makes it easy to assemble your blueprint visually, like positioning the lamp mesh and the light exactly where you need them. If we select the SM_lamp_ceiling on the left and click the magnifying glass in the details panel, it jumps straight to the static mesh in the content browser, the same mesh we worked with before. This makes it easy to find and reuse assets. Now we select the point light. This is exactly the same light type we placed manually in the level earlier. Here in the blueprint it works the same way. We move it slightly to the left, then compile and save. Back in the level view, we see that the point light sticks out to the left for all lamps created from this blueprint, because we changed it once in the blueprint and it updated everywhere. If we go back to the blueprint and move the point light back to its original position, compile and save, then return to the level view, we see the change is fixed everywhere instantly. This shows how powerful blueprints are. You build something once and use it 100 times in your level, and with just one edit, you update every single copy globally. That is why blueprints are such an important tool in Unreal. We will close this blueprint now and create our own simple example next. We navigate now to the Starter Content Blueprints folder where the ceiling light blueprint is stored. Right-click inside the folder and choose Blueprint class. You will see a prompt pop up. This is where you choose the parent class for your new blueprint, basically, what type of base logic your blueprint should have. At the bottom of this window, you can expand all classes. When you click this, Unreal shows you every possible class you can use as a base for your blueprint. It looks like a huge list at first, but do not worry. As you work with Unreal step by step, you will learn which classes you really need, and it will not feel overwhelming anymore, because everything has its place and purpose. For our simple example, we choose the actor blueprint. This is the same type of blueprint as the ceiling light we just used. It is a basic object you can place in the level that can hold components, logic, and variables. We name this new blueprint BP_mybp. The BP_ prefix stands for blueprint. It helps you keep things organized and tells you immediately this file is a blueprint asset. When we open BP_mybp, we see our empty blueprint in the viewport. Right now there is nothing inside it. On the left side in the Components panel, we click Add and create a new component called Static Mesh. A static mesh is any non-animated 3D object, like our chair, a table, or a prop. Now, just like we did with the sphere earlier, we look on the right side in the Details panel. Here we can set which mesh this static mesh component should use. We choose the chair mesh from our project. Again, we see the familiar transform section, because every mesh in the world needs a position, rotation, and scale. So even inside the blueprint, you can adjust exactly where and how big this part should be. For example, we can scale the chair down to 0.5. This means it is half the original size. This is really helpful if you want to make quick size adjustments directly in your blueprint instead of scaling each copy by hand in the level later. Now open the blueprint graph. Here you see 3 transparent nodes by default: Event Begin Play, Event Actor Begin Overlap, and Event Tick. These are starting points for your blueprint logic. Event Begin Play runs once when the game starts or when the blueprint spawns. Event Actor Begin Overlap triggers if another actor touches this blueprint. Event tick runs every single frame while the game is running, useful for things that must update constantly. If you right-click anywhere in the graph, the context menu appears. This is where you can search for any node you want, so you do not have to memorize where everything is. We search for the print string node and add it. This node is perfect for quick testing because it prints a simple message on screen while the game runs, so you can check if your logic works or debug what is happening. You see the white arrow pointing to the right on both nodes. This is an execution pin. It shows the order in which Unreal will run your logic. We grab the execution pin from the event begin play node and connect it to the inExec pin of print string. As soon as you connect it, you will see that begin play is no longer transparent, because it is now active and will execute when the game starts. The connection means that as soon as begin play fires, it tells print string to run next. In the inString field, we type hi, the chair BP started to play. This is the text that will appear on screen when the blueprint runs, so you know your chair blueprint is doing something. Some nodes have extra settings. When you expand print string, you can change the duration. We set it to 10 seconds so the message stays on screen longer, which makes it easy to see. Next, we grab the outExec pin from print string, drag it out, and when we let go, the context menu opens again automatically. We search for delay and add this node. The delay node pauses the logic for a set time before continuing. We set the duration here to 3 seconds, so it waits a bit before running the next part. This node now has a named execution pin, completed. That means Unreal will only fire the next action when the delay has finished waiting. From the completed pin we add another print string node. This time, the message is just 3 seconds finished. This shows you that your delay worked and the flow continues exactly as planned. Now we compile the blueprint. This checks for errors and saves the changes in the graph so they run in the game. Then we save and switch back to the level, ready to test that our blueprint runs step by step as expected. We search for a spot under the lamps and simply drag our blueprint into the level. Now we see our BP in action. It places the chair at half size exactly where we dropped it. This shows just how easy it is to create and use blueprints. Build it once, reuse it anywhere. If we hit play now, we see our message hi, the chair BP started to play appear at the top left. This comes directly from our chair over there, triggered by the blueprint's begin play. After 3 seconds, we see the second message pop up, 3 seconds finished, which only stays on screen for 2 seconds because we did not change the duration for that one. These messages were triggered by the event begin play, which fires immediately when the game starts, because the chair was already placed in the level. If we were to spawn this chair dynamically later on, the same messages would appear right when the chair spawns in. So now you have seen how powerful blueprints are, and how easy it is to use them to create smart, reusable objects that handle logic automatically and make your project much faster and cleaner to build. Next, let us take a look at materials and how to create them. We open the Materials folder in the Starter content, then right-click and choose Material. We name it m_my_material. The m_ prefix just helps you keep things organized so you always know it is a material asset, and we open it. In the material editor you see several parts. In the center is the graph, just like the blueprint graph. This is where you build your material logic with nodes and connect them visually. At the top left is the viewport for your material. Here you see how the material looks on a preview shape in real time. You have the same perspective controls as before. You can orbit, zoom, and pan to check the result from all angles. To the right is the preview mesh window. By default, the preview shape is a sphere, which is useful for seeing how the material behaves on a rounded surface. You can switch to cylinder if you want to see how it wraps around curved sides. The plane shows you the material on a flat surface, perfect for floors or walls. Next is the cube, so you can check how your material looks on boxy props. The last option is preview mesh. If you click it, you get a prompt because you need to choose an actual mesh first. To do that, press Ctrl+Space to open the content drawer. Find a mesh, for example, SM_couch, select it, then go back to the material view and click Preview Mesh Based. Now the couch appears in the preview, so you see exactly how this material will look when applied to that mesh in your level. At the bottom left is the Details panel for your material asset. It has tons of settings, and honestly, even I do not know every single one because materials can get super advanced. But do not let that scare you off. For now, you only need to focus on the basics. The main part is the graph, just like in blueprints. Here you connect nodes to define how your material works. Right-click in the graph. Just like in the blueprint graph, this opens the context menu with all available nodes. We search for constant 3 vector. This node gives you a simple RGB color input. Add it, then double-click the black rectangle inside the node to open the color picker. Pick a color, for example, a warm orange. The node has 4 output pins: white, red, green, and blue. The white pin carries the full color we just picked, so we use that. Drag the white pin and connect it to the base color input of the m_myMaterial node. This sets the overall surface color for the material. Now you see the preview mesh instantly updates, so if we give this material to a mesh, it will use this exact color. Switch the preview back to sphere and you will see your color on the default sphere, just like before. As an extra test, you can change the metallic value directly in the material node from 0 to 1, and in the preview, you see the material now looks metallic and shiny. This is enough for a first simple look. Click Apply to build the material with the current settings. This makes sure Unreal updates and compiles it. Then click Save to store it properly so you can use it anywhere in your project. We go back to the level view and select our BP_myBP chair in the scene. On the right in the Details panel you can see that the blueprint is selected. Here you have the same components view as inside the blueprint itself. You can see our static mesh component that we added earlier. If we select this static mesh component, you see our chair again, already scaled down to 0.5, just like we set it in the blueprint. Now we click the small magnifying glass to locate this mesh in the content browser, and double-click it to open the static mesh asset. Inside the static mesh editor, you see the mesh in the center viewport. This works just like the level viewport. You have the Gizmo settings for moving, rotating, and scaling, plus the perspective controls at the top right to orbit and inspect the mesh from any angle. You can move around freely here to check details and make sure everything looks right. At the top left, you have quick info about the mesh, for example, whether nanite is enabled or not, how many triangles it has, its size in units, and other important stats. This helps you keep an eye on performance and asset quality. On the right side you see the Details panel again. Here you define the default settings for this static mesh asset. We click on the m_chair material slot and change it to our new m_myMaterial that we just created. Now you can see our orange metallic material applied to the mesh in the preview right away. There are many more settings in this panel, but for now they are not important. We keep it simple, save the mesh, and switch back to the level. Back in the level, we see that our chair now uses the orange metallic material. If you look at any other chair that uses the same static mesh, you will see it also has the new material, because we changed it directly on the mesh, so all objects using this mesh update automatically. In the Details panel you can see that m_myMaterial is now set as the active material. This shows how easy it is to manage and update your materials in Unreal. One small change to the base asset, and all instances update at once. Now let us see how to create levels in Unreal Engine. In the Maps folder inside your starter content, right-click and choose Level. I name this new level my new level and open it with a double click. We see a black, empty level, and the outliner is completely empty too. This shows that nothing is in the scene yet. A level in Unreal Engine is like any playable area in your game. It could be your open world, a single mission, or even just your main menu. So every part of your game, big or small, lives inside a level. Now we drag our chair blueprint into the level, but you will see it stays completely dark. There are no lights, no sky, nothing yet, just pure black. This happens because Unreal needs real lighting and sky actors to make your scene visible. We could start adding lights and sky elements one by one, but that can be a bit tedious. To speed things up, Unreal offers the Environment Light Mixer, which you find under the window menu. This tool lets you build a full, realistic lighting setup with a few clicks, perfect for beginners. We click Create Sky Light. This adds soft, ambient light that makes your sky and shadows more realistic. It brightens up the dark areas in your scene. Next, we click Create Directional Light. This acts like the sun. It casts sharp light and shadows from one main direction, giving your scene clear highlights and shadows. Each time you click, you will see new actors appear in the outliner, so you always know what is added to your level. Then we click Create Sky Atmosphere. This gives your scene realistic sky colors, horizon fog, and sun scattering effects that make everything look natural. Next, we create volumetric clouds. These add dynamic, fluffy clouds to the sky that interact with sunlight, creating depth and realism. Finally, we add height fog. This gives your scene ground level fog that helps blend the sky and ground together, adding atmosphere and depth. When all these elements are in place, you can see that your level now looks similar to the starter level, with realistic light, sky, clouds, and fog all working together. It takes just a few clicks, and you have a great base to build on. If you hold Ctrl+L and move your mouse, you can change the sun's position in your level. This rotates the directional light in real time, so you see how the sunlight, shadows, and even the sky atmosphere update instantly. The whole lighting adjusts dynamically, which makes it super easy to find the perfect time of day for your scene. We can now select the sky atmosphere actor and, for example, change settings like Rayleigh scattering. This controls how light scatters in the atmosphere and affects the sky's color gradient, so with just a few tweaks, you can create sunrise, sunset, or a clear midday look. Or you can select the directional light and change its intensity to make the sun brighter or dimmer, depending on how strong you want your sunlight. You can also adjust the light color, for example, set it to pink to create a dramatic, stylized sunset. The directional light has tons of other settings to help you fine-tune your lighting until it fits exactly what you want. Now, let me show you another way to create a level. Go to File, then New Level. This opens a prompt where you can choose how you want to start. There are three options: Empty Level, which gives you a completely clean slate; Basic Level, which adds a simple light and floor so you do not start in total darkness; or Open World Level, which sets up a landscape-based world for large outdoor maps. We choose Open World and click Create. Unreal creates a huge open world level made of landscape proxies. These are individual pieces of terrain stitched together to form massive worlds that can be streamed and managed easily. Again, you can hold Ctrl+L here too and adjust the sun's position, and you will see how the light sweeps across the landscape. It already looks really impressive, and you did not even add any content yet. You can select each proxy and see in the outliner how they are organized and named, super helpful for managing really big environments. The next step is to save this new level. Click File, then Save Current Level As. Choose the folder where you want to keep it, give it a name, and save it. This keeps your work clean and organized. Now, let us switch back to our LVL third-person level via File, then Recent Levels. If we hold Ctrl+L here and rotate the sun, you will see how beautifully the light, shadows, and global illumination, thanks to Lumen, adapt in real time. The engine calculates all of this dynamically for you, so you do not have to bake or rebuild light every time. That is the real power of Unreal Engine, especially for beginners. It takes so much technical work off your shoulders and lets you focus on building your world and telling your story. One more cool thing about Lumen in this engine: it is Unreal's real-time global illumination and reflection system. That means light bounces, indirect lighting, and even subtle color bleeding happen automatically while you work. You can move a light, open a door, or change the time of day, and Lumen updates everything instantly, no baking needed. This gives your scenes a super realistic look without you spending hours tweaking static light maps or waiting for long build times. It is an absolute game changer for fast, believable lighting, and especially for beginners. It makes experimenting with light and mood really fun instead of frustrating. So, we have now covered most of the core basics I wanted to show you. There are just two more important tools left: Quixel Bridge and the Fab Store. Let's start with Quixel Bridge. You can open it directly under Window, and you will find it as your direct link to thousands of high-quality Megascans assets, ready to drop into your level. To use Quixel Bridge, you first need to sign in. Just click the Login button at the top right. Once you are signed in, you can use the globe icon to browse all the categories, like 3D assets, for example. Inside 3D assets, you can refine your search. For example, search for a boat. Once you find something you like, you can select it, choose the quality level you want, and then click Download to grab the asset. This downloads the high-quality scanned asset straight into your project, so you can place it just like any other mesh. This makes it super easy to get high-quality props fast. In my case, I sometimes get an error that says asset not available in UAsset format. I honestly do not know exactly why that happens. But here is a trick. You can also just drag the asset straight from Quixel Bridge into your level, even if you get that error. This spawns a lower quality version directly into your scene. For whatever reason, that works just fine. And you can do this with any asset you want, so do not worry if the download option fails, just drag and drop it. This is just a quick example to show you how powerful Quixel Bridge is. We will not go deeper for now because I want to show you the Fab Store, which is even more interesting at the moment. In the Fab Store, you have a huge library of assets you can use to build your project. On the left side you can browse by category, like 3D assets, environment, materials and textures, sprites, animations, game systems, templates, and much more. Many products here cost money, but there are also plenty of free assets. You can use the filters at the top to adjust what you see. For example, under Price, click Free, and it will only show free assets you can use immediately. For our example, let us pick the African Animal Pack. Click on it and you will see details about what is included. You can add it to your library. This keeps the asset available for all your projects anytime. Or you can click Add to Project to bring it straight into your current project. When you do that, you have to accept the license agreement first. After accepting, a prompt will appear asking you to choose the engine version. Pick 5.5. This is fine for 5.62 because they are compatible. Click Add to Project again and the download starts automatically. When the download finishes, switch back to Unreal. In the content browser, you will now see a new folder named African Animal Pack. Inside you will find 6 subfolders, each for a different animal, like the crocodile or the elephant, and each animal has its own subfolders for animations, blueprints, materials, textures, and more. Open the Blueprints folder and you will find the BP_elephant blueprint. Drag it into your level, and you will see your big elephant appear in your scene, ready to go. We place the elephant somewhere in the level where we have enough space and rotate it slightly so it faces nicely into the scene. Then we start play mode, and right away we see our boat with the life buoy in place, and on the left, our elephant is calmly playing its idle animation automatically. It already looks great with just a simple setup. Now we stop play mode and open the BP_elephant blueprint. In the event graph, we can see a few predefined nodes that handle the logic to make sure the elephant plays its idle animation as soon as it spawns. In the viewport, we see the elephant mesh. Exactly the same principle we saw with the lamp or the chair blueprint earlier. Here, a skeletal mesh component is used. This component is needed for any mesh that has bones and needs to play animations, like characters or animals. On the right in the details panel, you see that the assigned mesh is called SK_elephant. SK stands for skeletal mesh. This means the asset has a skeleton inside, which allows it to play animations. You can also see which material is used to give the elephant its look. In the event graph, we see the logic that runs when the elephant spawns. The interesting part is the last node, called Play Animation. This node tells Unreal to play a specific animation on a skeletal mesh when the blueprint runs. Here you see that the skeletal mesh is set as the target for the Play Animation node, so the node knows exactly which mesh to affect. In the new Anim to Play slot, you could easily swap the idle animation for a combat animation, for example. So with just one setting, you change how your elephant behaves. We compile and save the blueprint, switch back to the level, and start play mode again. Now our elephant no longer stands idle. It loops the attack combat animation instead. And this shows exactly how useful blueprints are. You build the logic once, reuse it as often as you like, swap animations or meshes in seconds, and keep full control. It is a powerful way to make your world feel alive without doing everything manually every single time. We select the elephant in our level and check the details panel. Here you can see that our BP_elephant is selected. We can click on the skeletal mesh slot, just like we did earlier inside the blueprint's viewport, and here below we see the settings for the assigned mesh and the material that is used for it. We browse to the material, click the magnifying glass to jump to it in the content browser, and open it. Now we see the material that gives the elephant its skin look. Inside the material editor, you can see how this is set up. There is a texture sample node connected directly to the base color input. This means the texture you see on the elephant comes straight from this connection. It defines the surface color. We select the texture sample node and look on the left in the details panel. Here, under material expression texture base, we can switch the texture to something else, for example, to a brick stone texture. After changing it, we click apply and save. If we look back at the level now, we see our elephant has turned into a stone elephant with a brick pattern on its skin. This works instantly because the material is connected directly to the mesh. We can go back to the material, press Ctrl+Z to undo the texture change, click apply and save again, and then switch back to the level. Now the elephant has its original texture back exactly as before. One last thing I want to show you is the maps folder inside the elephant asset pack. Here you usually find an overview level, a small sample scene that shows you how the asset looks with light and setup. We can open it, but remember, before opening any new level, always make sure to save your current level so that no changes are lost. In this map, you have a nice preview setup for the elephant with all its animations ready to check out. You can hit play mode, run around, and watch all the animations in action, or you press F8 to detach the player, so you can fly around freely and inspect everything in peace without controlling the character. And with that, we have reached the end of this video. We covered a lot, but now you have a solid first look at what is possible inside Unreal Engine and how you can work with it step by step. We learned how to set up the Epic launcher, install the engine, and navigate the editor. We looked at how to use the viewport, move around the scene, adjust lights and sky settings, and build simple props with blueprints. We explored how to set up basic materials, use Quixel Bridge and the Fab Store to bring assets into your project, and how to work with levels, lighting setups, and real-time rendering features like Lumen. Most importantly, you have seen how powerful and flexible Unreal systems are, how you can create logic once, reuse it anywhere, swap out meshes, materials, and animations with just a few clicks, and build impressive scenes quickly even as a beginner. This is just the beginning, and I hope you are excited to keep learning and create something amazing with Unreal Engine. If you enjoyed this video, feel free to leave a like or hit subscribe so you do not miss any of the upcoming episodes. This video was all about first steps, perfect for beginners who want to get comfortable inside Unreal Engine. The next video will go deeper, with more advanced workflows and tools to help you understand even more of what this engine can do. If you want to take it even further, you can also check out my MSG course. This is a premium training where you learn from scratch how to build a complete game step by step. Inside the MSG course you will learn how to set up motion matching, create a fully functional inventory system, build an ability system similar to gas with attributes and gameplay effects, design a crafting system, set up a building system, handle professional level design and so much more. Everything is explained beginner-friendly, with full German and English support to help you at every step. Have fun exploring Unreal Engine, and I wish you all the best for building your dream game. The road can be tough, but every bit of progress is worth it. Keep going and see you in the next one.